Hello, this is Miss Martinez, and I'm going to be going over questions 1 through 7 from the ACP Sample Items. So here's question number 1. Which statement correctly compares nuclear fusion and nuclear fission? For this question, you really just need to know the definitions. Fusion means to fuse together, so you're taking two small elements, putting them together, making a bigger one. Fission means to break apart. So to fizz is to break apart. So you're taking one big atom and breaking it down into smaller ones. So A, fission requires a high density and high temperature environment, while fusion requires high speed neutrons to initiate. We didn't really talk about that, so not A. B, fission requires little energy to initiate, while fusion requires extremely high energy input. We didn't talk about that either. C, fission is the splitting of a large atom into two or more smaller ones, while fusion is the union of two or more lighter atoms in a larger one. That sounds like what I said earlier. And D, fission is the union of two or more lighter atoms into a larger one, while fusion is the splitting of a large atom into two or more smaller ones. That's the opposite of what's true. So our answer here is C. Okay, for question number 2, which reaction produces an insoluble product? You are going to need to use your reference sheet, like this one on the right. You're going to use your solubility rules. So the first thing you need to do is make sure that you're not doing any extra work. So the question says, which produces an insoluble product? A product is something that is produced, so it's going to be on the right side of your arrow, which means that for all of these answer choices, you can completely ignore the reactants. We're not looking at those. We're just going to focus on the products. So you have to go one by one, each substance, look at the anion first, which is the second element, find it on your list, see if you have any exceptions, and go from there. So our first answer choice A, PbI2. I is down here. I is soluble, except when it's bonded to silver, lead, or mercury. We do have lead right there, which is an exception, which means that this compound is not soluble, but instead is insoluble. So immediately we found an insoluble product right here. However, you should go and check the rest of them just to be sure. So the second one, KNO3, there should be a 3 right there. You look for, sorry about that, NO3. NO3 is right here. It's soluble. There are no exceptions. That means it's always soluble. So that's a soluble product. But the question only asks for one insoluble product, which means A could still be our answer. But let's check the rest of them anyway. So then we have CaNO3 for answer choice B. Again, NO3 is always soluble. It doesn't have any exceptions. So that's a soluble product. Then we have AgC2H3O2. C2H3O2 is up here. There are no exceptions, which means that entire compound is still soluble. Answer choice C, AlCl3. Cl is down here. It's soluble. The exceptions are silver, lead, and mercury. We don't have that. We have aluminum, so that's still soluble. Next, we have BAS. S is down here, which means it's insoluble unless it's bonded with NH4, alkali metals, Ca, Sr, or Ba. We do have Ba, which means it's not insoluble anymore. Now it's soluble, so that's not our answer either. MgBr2, Br is down here. It's soluble unless it's bonded with silver, lead, or mercury, which it's not, so the whole thing is soluble still. And our last one, SrOH2. OH is down here at the bottom. It's insoluble unless it's bonded with ammonium, alkali metals, calcium, strontium, or barium. We do have strontium, which means it's no longer insoluble. Now it's soluble, meaning our answer is still A. All right, question number 3. You are still using your solubility rules. This time it's asking you which substances are soluble in water, and you're selecting 2 correct answers. As we saw from the previous question, NO3 is always soluble because it does not have any exceptions. So immediately we know A is going to be one of our answers because NO3 is always going to be soluble. Then we have PbCO3. CO3 is down here. It's insoluble unless it's with ammonia or an alkali metal, which it's not, which means B is insoluble, so that can't be our answer. C is Ag3PO4. PO4 is down here at the bottom, meaning it's insoluble unless it's bonded with ammonium or an alkali metal. Silver is not ammonium or an alkali metal, which means it's still insoluble, so C is not our answer either. D is CnCrO4 CrO4, I kind of blocked it out. It's right there. CrO4 is insoluble unless it's bonded with ammonium or an alkali metal. Tin is neither of those, so D is not our answer either. And finally, E, NH4Cl. You could do this by looking at either the cation or the anion. So starting with Cl, that's soluble, unless it's bonded with silver, lead, or mercury, which it's not. So the whole thing is still soluble. Or you could look at the fact that it has NH4. And if you look at NH4 plus up here, there are no exceptions, which means it's always going to be soluble. So our answers here are A and E. Question number 5. There are 70 grams of 4 salts added to 100 grams of water in 4 separate beakers. The water in all 4 beakers is held at 50 degrees Celsius. Which salt makes an unsaturated solution? So a few things to remember. The 100 grams of water, you don't really need that information because on a solubility curve, everything is in 100 grams of water. You also need to know what an unsaturated solution looks like on a graph. That means your point should be below the line. All 4 beakers are at 50 degrees Celsius. We have 70 grams. So your grams are your y-axis. Your temperature is your x-axis. So 50 degrees, 70 grams is somewhere around here. And now you're going to look through your answer choices, look for those lines, and pick the one that's above your point. So KNO3 is right here. Our point is below it, which means that's a good answer. That would be an unsaturated solution. So let's circle it for now. B is NaCl. NaCl is down here, which means the point is above it. That would be a saturated solution or supersaturated. Depends on whether all of it dissolved or not, so that can't be right. C is KClO3. KClO3 is down here. Again, our point is above it, which means depending on whether it all dissolved or not, it would be either saturated or supersaturated. So C is not right either. D is K2Cr2O7, which is here. I'm going to assume that's a typo, which means, again, our point is above the line. Again, if all of it dissolved, it's supersaturated. If only some of it dissolved, saturated. Regardless, that can't be our answer either. So our answer is A. KNO3 was the only unsaturated solution. Okay, for question 5, this is actually 5. The previous one was 4, sorry. You are using calorimetry. So a student used calorimetry to determine the heat lost by a piece of candy as it cooled. She placed the candy in a beaker of water. The table shows the measurements she used during her experiment and the known value she used for the specific heat of water. Based on the values in the table, how much heat was lost by the candy? So in your reference sheet, you have the equation for specific heat, which is Q equals mc delta T. And we learned in class that heat lost, so negative Q, is equal to heat gained, positive Q. So in this question, the candy is losing heat, so that would be our negative Q. The water is gaining heat, that would be our positive Q. And we know they have to be equal to each other. So if you read the question carefully, it's just asking you for the heat that was lost by the candy. So it's just asking you for negative Q. We can't calculate negative Q because we don't have a specific heat for the candy, but we do have a specific heat for the water, which means what we can do is calculate the positive Q. Sorry. And we know that the positive Q is equal to the negative Q. So whatever number we get for that positive Q will be our answer for the heat that was lost by the candy, because they should be equal. So you're going to start by listing your variables. So you should have your M, your C, and your delta T. And we're doing this for our water. So the mass of the water is 100 grams. The specific heat of water is in the problem, but you should memorize it just in case they don't give it to you. That's 4.18. And then the change in temperature would be the final minus the initial. So for the water, it was initially at 24 degrees. The final temperature was at 26 degrees. So 26 minus 24 is 2. So the change in temperature is 2. So now you would just have to plug that into your calculator to get your answer. So you would do Q equals MC delta T, which means you're going to do Q equals 100 times 4.18 times 2, which is 836 joules. And if that's our positive Q, then that means that should also equal our negative Q. So our answer here is B. Question number 6, which term describes a substance that is completely consumed during a chemical reaction? This is another just vocabulary question. You just have to know the definitions. So a excess reactant, it's in the word, it's excess, it means too much. So this is the one where you have some of it left over. The limiting reactant is limited. So that's the one that you completely consume. So completely consumed is your limiting reactant, means the answer is B. All right, question number 7 says, the table shows some of the assumptions of the kinetic molecular theory of gases. What assumption can be added to this list? So gases have no definite volume. Gas particles are in continuous random motion. The average kinetic energy is the same for all gases at a given temperature. All of that is true. We have our answer choices up at the top. Collisions between particles and container walls are inelastic. That is incorrect. The word that should be there for it to be true should be elastic. So you learned that gases have elastic collisions. So it can't be that first one. The second one says the temperature of a gas depends on the average potential energy of the particles. We have not mentioned potential energy at all in this class. This is called the kinetic molecular theory of gases. So that's incorrect. So it can't be that one. Gas particles are much larger than the distance between them. That's not true. You saw in the PhET simulation, hopefully you did in class, gas particles are very, very small and there's a big distance between them. So it can't be that one. And finally, the volume of a gas is mostly empty space. This is true. So since the gas particles are so small and they're so far apart from each other, it ends up being that most of the volume is just empty space. So that you would have to move to the box down here.